In this lecture, we are going to talk about plant shoots. Shoots include both the stems as well as the leaves. I'm going to give you a warning that this lecture is fairly heavy in vocabulary. While the vocabulary itself is not very interesting, it is really necessary for us to go over it. The reason is that if we didn't have the same terminology as everybody else in describing plant parts, then it would be difficult or even virtually impossible to communicate about the plants. For example, the way that we often identify plants is by reading a guide that somebody has written. So if that person who wrote the guide is using different terminology than what we ourselves are using, then it would be very hard to know whether we were looking at the same plant that the author described. So in this lecture, there's a lot of terminology. You will have a chance to practice using that terminology in the laboratory portion of the course. There's going to be a point in laboratory where you practice identifying plants based on characteristics of their woody stems. And there's also going to be a point where you go out and look for leaves with different characteristics. And you also are going to eventually identify plants based on their leaf or stem characteristics. This lecture focuses on plant shoots, which include stems and leaves. First, we're going to talk about organ systems as well as organs in the context of plants. Then we are going to focus exclusively on shoots, which we just defined, and we are going to go over various aspects of stem external morphology. We're going to talk both about stems in general and about woody stems more specifically. They have several additional characteristics. Then we'll switch from talking about the stems to talking about the leaves. We'll talk about leaf arrangement, and then we will go over leaf external morphology. In other words, different kinds of leaf shapes. Plants have two kinds of organ systems. The first is the shoot system, which we've already said encompasses the stems as well as the leaves, and then there's the root system. So in the shoot system, the vegetative parts we've just mentioned, stems and leaves. There can also be reproductive organs if the plant is mature and it's the right season. If there are reproductive organs, these can include the flowers or later the fruit. Roots are much more simple. The only organ in the root system is the roots themselves. So focusing on shoots. They are usually above ground, and something important to know about plants is that the elongation always happens at the tip. So along the stem, most of the stem will not be growing or elongating. Instead, all of the new growth is going to happen up here at the apex or the top of the stem. And just below that region, there can be a little bit of elongation where cells lengthen. Then below that, there's going to be no additional substantial lengthening of the stem. So this area at the very top of the stem is called the apex for singular, or the plural of that is apices. And within this region is the apical meristem. This is the region of dividing cells that is going to allow growth and elongation. During the growing season, the apical meristem is not going to be covered by scales. However, in temperate areas like South Carolina, then oftentimes there's a cold season where the stem is going to go dormant. During that season, then the stem is going to be protected by hard leaf-like appendages that are called scales. While we're talking generally about stems, we should point out two sections of stems. One is the node. The node is the point where the leaf connects to the stem. So this is a node right here, and this is also a node right here by this other leaf. And then there's always some space between the two nodes. Because it's in between them, we simply call it the internode. Internodes can vary in their length. In some plants, like many vines for example, the internode can be very long. In other plants, the internode can be very short, sometimes not even noticeable with the naked eye. And the result of having a very short internode is shown in this picture over here on the right. This form is called a basal rosette, and that's because the leaves sort of look like rose petals. And you can see there's almost no space between them. They're more or less sitting right on top of one another. So we've said that the nodes are the point of leaf attachment. There is another structure that occurs at each node. These are axillary buds. Axillary buds include a dormant meristem in the leaf axils. And the axillary bud, so the axil of the leaf is this angle right here. The axillary bud will always be on the apical side of that, towards the tip of the stem. Usually this meristem is going to be protected by scales, and that's to keep it from being damaged from herbivores or from the weather. These axillary buds are usually going to be dormant. However, if something happens, for example, if the top of the stem is bitten off by an herbivore, then these axillary buds can become active and they can elongate into their own stem. Also sometimes, an axillary bud that is far down, far away from the tip, might simply become active such that the plant can grow a new stem and look for light in a new area. The arrangement of leaves as well as axillary buds along the stem can vary between species, and this is a characteristic that we use as one way of helping to identify different plants. So the terminology or the term phyllotaxy refers to the arrangement of leaves along a stem. One arrangement that's possible is to always have two leaves across from each other on the stem, such as in this diagram at the left. And this is called opposite because the leaves are opposite one another. Another possibility is that the leaves alternate going up the stem, and this arrangement is called alternate. A third possibility is that there are nodes along the stem that have more than two leaves. This could be 3 or 4 or even 6 leaves, for example. But so long as each node has more than 2 leaves, this arrangement is called whorled. What we've just talked about would apply to any kind of stem. Woody stems are ones that persist for multiple years, and they thicken each year. So these are going to be the kinds of stems we would see on a shrub or tree. And these have several additional characteristics, such as aspects of the buds, the bud scales, the nodes, etc., that are going to help us be able to identify plants, even in the wintertime when those plants lack leaves. On the right here, we have a diagram of a woody stem. We will go over several terms about this. The first term is lenticule. A lenticule is an opening in the bark for gas exchange. In practice, these often look like little dots scattered around the stem, as shown here. Second, we will talk about bud scale scars. Bud scales, remember, are these hard protective coverings around the apical meristem. Each year, after the winter, when the apical meristem becomes active again, these bud scales fall off. However, the point where they were attached to the stem leaves a mark. So if we look down the stem to where it had started to grow during the previous spring, we will see these marks that go a good portion of the way around the stem, and those are the bud scale scars. So the distance from the bud scale scar to the apex, from here to here, is an indication of how far this plant grew since the last dormant, or in this area, the last winter season. While we're talking about scars, the next thing we will look for are stipular scars. Stipules are small leaf-like appendages attached at the nodes. So when this plant had leaves, the leaves were attached, let's say, here and here. On some species, there are some very small leaflet-like appendages that are attached right at the base. When those fall off, they also leave scars. So this line here, as well as this line, are stipular scars. And we can see another stipular scar, for example, right here. Next, we get a scar when the leaf itself falls off. And we were just looking at a couple of these. This circle here is a leaf scar, as well as this and this, for example. Within the leaf scar, there are marks where the veins used to attach between the stem and the leaf. These veins are technically called vascular bundles, and so the marks left behind where the veins were are called bundle scars. Again, on this diagram, we can see nodes as well as internodes. So here's a node around the leaf scar and the axillary bud, then an internode going up to the next leaf scar. Next, we will talk about armature. Armature is a fancy word for anything sharp along a plant stem. This can include prickles, thorns, or spines. We often use these words interchangeably, but technically they each have a different meaning. So prickles are the armature that is only attached to the very outer layers of the stem. And importantly, prickles lack vascular tissue. So over here on the right, this diagram, we can see that the sharp appendage is only attached on the outside, and it is not attached to these red lines, which represent the vascular tissue. Therefore, this appendage is a prickle. Next, we can talk about thorns. Thorns are actually modified branches, and branches always have vascular tissue. So that means that thorns themselves also have vascular tissue. And you can see that on this diagram on the left. The vascular tissue comes up and it enters the thorn, and then it continues going up the remainder of the stem. In practice, it can be hard to see whether a kind of armature has vascular tissue or not. One rule of thumb, if you are not in a classroom setting, you can try to break off the armature. If it breaks off very easily, and it doesn't leave much of a scar on the stem, then it's a prickle. If it's harder to break off, and you can see a bundle scar when you do break it off, then it's a thorn. Finally, we can define spines. Spines are not part of the stem. Instead, they are modified leaves or sometimes modified parts of leaves. So we'll look at a few examples of these here. Let's start first with this example at the far right. What we're looking at here is a portion of a cactus, and the flat green surface in the background is really the stem of the cactus. What's missing on the cactus then are leaves, and we can ask where the leaves are. In fact, in the cactus, the leaves have been modified into these sharp appendages. So in a cactus, these sharp appendages are actually spines because they are modified leaves. Let's go to the middle picture now, and you can see that along the stem, at regular intervals, so here and here and here, we are getting sharp armature. The armature is fairly large. Also notice that it's laid out much like leaves or axillary buds would be at regular intervals. So that's a good clue that, in fact, these are probably modified from the axillary buds, but remember, axillary buds are things that can become stems. So if these are modified from axillary buds, that would make each one of these a thorn. Finally, in this third picture, you can see again that there's armature, but this time there are many small bits of armature, and they are not separated as they are in this middle picture with a node and an internode. Instead, they're sort of hodgepodge around the stem. They are smaller, and if you broke them off, you would see that there was not vasculature underneath. That makes these prickles. So we're going to move on now from the stems to the leaves. And leaves, of course, are organs that are used to perform photosynthesis. The book describes the following information. First, why are leaves thin? Second, why are leaves broad, typically? And third, why do leaves have a network of veins? So you'll be expected to know this, and it is in the assigned reading. Now we're going to go over general leaf morphology. We're going to start with a couple of terms you are probably familiar with. The first is the petiole. And the petiole is stem-like tissue that connects the blade to the stem in most plant species. It's not truly a stem because it's part of the leaf, but it's acting like a stem. And so here on the diagram is a petiole. The remainder of the leaf then is the blade, and this is the flattened portion of a leaf that is specialized for photosynthesis. So this whole section up here is the blade. One way we can identify plants is by how the veins in the leaf are oriented. There are many possibilities, but two pretty general possibilities are having parallel veins, as shown here. So they're not exactly parallel, but they don't intersect with each other, except at the very base and perhaps at the very top of the leaf. You see there's not a lot of cross veins going back and forth between them. The alternative possibility is that the veins are netted or reticulate. So that means that the veins branch off from one another. They also reconnect to one another. You can see that in several places around this leaf. The next distinction we can make with regard to leaves is whether they have simple or compound leaves. A simple leaf is one undivided blade, as shown in this picture at the top right of the slide. So there's one petiole, and it goes to a single blade. One way you can tell this is a single leaf, remember there would be an axillary bud somewhere associated with the base of this petiole. An alternative to a simple leaf is a compound leaf. Compound leaves have the blade divided all the way down to the central vein, and this forms multiple leaflets. If we have a compound leaf, there are three different ways that the leaflets can be arranged. The leaflets can be pinnately compound, as shown in this diagram on the left. In the pinnately compound leaflet, there's a long central axis, and the leaflets are attached to that central axis. An alternative is a palmately compound arrangement, as shown in this center picture. And in a palmately compound arrangement, leaflets radiate from a central point. There have to be more than 3 leaflets to count as palmately compound. So in this example, there are 5. The third way leaflets can be arranged is they can be trifoliate. Tri means 3, foliate means leaves. So this is the 3 leaflets. And the reason this gets its own name is because this looks something like a pinnately compound leaf, and it looks something like a palmately compound leaf. And so we solved that problem by giving it its own name. Before we move on, I should point out that sometimes a pinnately compound leaf has one leaflet at the very top. In this case, it doesn't. Now, it can be difficult when a plant has compound leaves to know whether, in fact, it has compound leaves or whether, in fact, each of these appendages is a leaf in itself and the center axis is a stem. So here are some ways you can tell the difference between those. The first way is that on a compound leaf, there's usually going to be a regular repeating pattern of the leaflets. So the leaflets are always going to lie flat in the plane. They're never going to be coming out towards us or going away from us if you lay the leaf down, let's say, flat on the table. Second, the pattern between the leaflets on different leaves is going to be similar. So if this leaf has about 7 pairs of leaflets, most other leaves on that tree will have somewhere around 7 pairs of leaflets, and the arrangement will be the same. Since these leaflets are opposite each other, that's probably true on the other leaves. Something else you can look for, where this attaches to the main stem, there should be an axillary bud if this is a leaf. If this is really just a branch, then there would not be an axillary bud associated with it. Now we're going to talk about some different leaf shapes. And we're going to do this by talking about overall leaf shapes to start with. So not just a part of the leaf, but the leaf as a whole. Then we're going to go over terms that just apply to the apex or the tip of the leaf. Then we are going to go over terms that just apply to the base of the leaf. Then we are going to go over terms that apply to the edges of the leaf. Let's start with the overall leaf blade shapes. You can see there's about 7 or 8 different terms that you'll need to know. Oh, actually there's 9. On this first one is an ovate leaf. And this is a pretty common leaf shape. You can see that it widens, but the widest part of the leaf is a little bit closer to the petiole or the base of the leaf than it is to the apex. So the widest part is about right here, and the center of this leaf is further up, like about right here. So that's an ovate leaf. Next, we can look at an orbicular leaf. Orb means spherical, so this isn't truly spherical, but it's at least a round leaf. That's fairly straightforward. Next, let's look at an obovate leaf, and let's contrast that with the ovate leaf. Their shapes are actually pretty similar. They're both egg-shaped. The difference is that in an obovate leaf, the widest part of the leaf is closer to the apex than the base of the leaf. So the widest part is about here, and here about is the midline on this leaf. Next, we will look at an elliptic leaf. And in an elliptic leaf, then again it's oval-shaped, but this time the widest point is just about at the center of the leaf. If we move down to the second row, we see several shapes. The first is needle-shaped, and the needle shape is basically very long and very thin. In this example, it widens a little bit in the middle, but oftentimes it just looks kind of like a narrow cylinder, the same width, its entire length. Next is an awl-shaped leaf, and in this shape, it is widest at the base, and then it narrows or tapers to a point at the other end. We next have a lanceolate leaf, and this is similar to awl-shaped. The difference is that it is pointed at both ends of the leaf, both at the apex as well as the base. We next have a chordate leaf, and the chordate leaf looks heart-shaped. So if you just flip this such that the base was sticking up, it would look like a heart you would draw, let's say, in elementary school. Finally, we have a deltoid leaf, and delta means triangular, so this leaf basically has a triangular shape, flat along the bottom and then coming to a point at the apex. We are next going to focus on the shape of leaves only at their tip, not worrying about the remainder of the leaf. We have about 6 terms here. The first term is acuminate, and this refers to a leaf that increasingly tapers and gets narrower and narrower towards the tip. Compare that to an acute leaf. An acute leaf is sharply pointed, but it doesn't taper and get narrower and narrower as it goes. And the way to tell whether a leaf is acute or obtuse, which is our next picture, is to hold a piece of paper against it. If the angle is less than 90 degrees, so sharper than the corner of the piece of paper, it's acute. If the leaf comes to a point, however, the angle is wider than the corner of a piece of paper, then that is an obtuse leaf. Another possibility is that there's really no point at all, and it's hard to even tell where the end of the leaf is. This is simply called rounded. Another possibility is that the leaf is really flat across the top, as if it's been cut off. This is referred to as truncate. Finally, another possibility is that the leaf is rounded near the top, except for right near the center, there is a point that sticks up where the central vein that is met by the central vein. And this arrangement is called mucronate. Did I mention that botanists love terminology? So I know this seems like a lot of terms. However, I will point out that I'm only teaching you a small fraction of the terms that are used in describing leaf shape. These are the most common. So, with that aside, we are next going to talk about the shape of leaf bases. The first possible shape is acute, and this is pretty similar to what the term meant when we talked about it in relation to the apex. The base comes to a point, and that point is narrower than 90 degrees. Next we have cuneate. Cuneate is similar to acuminate for a leaf tip. It is a base that tapers and gets increasingly more sharp as it gets closer and closer to the base. The next shape is oblique, and the important thing for an oblique leaf is that the two sides are not symmetrical. So you can see if you folded this in half, the two sides would not line up. I will warn you that any leaf you look at, if you look really closely, it's never going to be perfectly symmetrical. However, for a leaf where we use the term oblique, it's really very easily noticeable that it is asymmetric. Another term that is used for this, I'm just going to mention it in case it comes up in laboratory, is inequilateral. So the two sides are unequal or inequilateral. We had the term rounded for leaf tips, and we can use that term for leaf bases. We had the term truncate, which meant cut straight across. For tips, that also applies to bases. And we had the term chordate for leaf as a whole. We can also use the term chordate for just the bottom of the leaf if it has this heart lobe-like arrangement. And we're getting close. The next set of terms we need to talk about apply to the leaf margins. So these are the edges of the leaf. Sometimes they're along the edge, there's really nothing interesting going on. It's just smooth. The term we used for this is entire, as in it's entirely without teeth. If the leaf does have some sort of teeth, then we need to describe what kind of teeth. So the first term we'll talk about is dentate. Dentate referring to teeth, and these look sort of like maybe an alligator, at least a cartoon drawing of an alligator's teeth. The teeth are symmetrical, left to right, They often look like they are more or less pointing outwards rather than pointing forwards. Our next term is crenate, and crenate margins have rounded teeth. They're not sharp. Even if the leaf was hard, these would not cut you or snag in your clothes. Serrate refers to teeth that are forward pointing. So we said that dentate had symmetrical teeth. Here you can see that the teeth are not symmetrical. If you draw a line down the middle, the left and right do not resemble one another. This leaf is singly serrate, or just normally serrate. There's just one set of tooth sizes. We can, however, have doubly serrate leaves. In this case, we have big teeth that again are forward pointing, but leading up to each of those teeth are a series of smaller teeth. So it's sort of teeth within teeth. Because there's two layers, it's called doubly serrate. Another possibility is that the edge looks very wave-like. If you remember to geometry, what a sine wave looks like on a graph, it looks something like this, and so this is called sinuate. We can also have very small teeth. This is similar to serrate, it's just that these are much smaller, sometimes even hard to see if you don't look without a magnifier, and this is called cerulate. We already talked about entire. The last feature of leaves we need to talk about is lobing. Lobes refer to these large areas that stick out towards the side of a leaf, or conversely, we could think about it as large indentations that come in and interrupt the leaf blade. And that's true both here and here, areas that stick out or indentations that come in. So these are called lobes, and if we have lobes, there are two possible arrangements. The first is that the lobes can be arranged like the fingers on your hand, and this would be analogous to the palm of your hand. So this arrangement is called palmately lobed. The other possibility is that the lobes stick out towards the side, much like the strands on the feather stick out to the side, and so we call this pinnately lobed. This distinction is analogous to the distinction between palmately compound and pinnately compound leaves. Okay, that brings us to an end for this lecture. I did warn you that there would be a lot of terminology here, and while this terminology is a lot to remember, it is going to be invaluable as we try to identify plants with keys. So you will get abundant practice using these terms as we go ahead and do laboratory assignments relating to stems and relating to leaves.